So last lecture, we found the best response correspondence of a firm in a Cournot duopoly. So we were trying to do the same thing using indifference curves. In this case, iso-profit curves. So let me write the numerical representation of the preference of a firm. Let's say firm 1. So profits were, we used profit as a numerical representation of the preference relation of firm 1. And what we had was Q1 alpha minus C minus Q1 minus Q2. If Q1 plus Q2 was less than or equal to alpha, it was minus C Q1. If, well, otherwise, if Q1 plus Q2 is bigger than alpha. That's what I should refuel. That's what we had. We were trying to draw the iso curves. Okay, so indifference curves, iso-profit curves. So one thing we noticed is the behavior of the numerical representation, the profit function changes depending on which region you are. So we said, let's break the first quadrant into 2 regions. The region where Q1 plus Q2 is bigger than alpha, the region where Q1 plus Q2 is less than alpha, and we have equality, which already falls into one of the regions. Okay, so we started with the simple. If we're in this region, the profit function behaves in this manner. So to keep this constant, Q1 should be constant, and there is no restriction on Q2, except that it should lie in this region. So last lecture, we discovered that iso curves in this region, iso-profit curves, indifference curves looked like this, with the direction of increasing preferences in this direction. Okay? So note that C is positive, Q1 is positive. So in this region, profit is negative. Okay? So as we move, so in this region, the firm is losing money. As we move in this direction, it's losing less money. Okay? So this part we took care of. So now we were concentrating on this part. So there we had, on that region, Q1 times alpha minus C minus Q1 minus Q2. We set it equal to some number K. Okay. So last time I said, to simplify things, I divided both sides by Q1 and assumed Q1 was different than 0. Let's take a different approach. So if Q1 is equal to 0, K is equal to 0. So let me consider the case, what happens first when K is equal to 0. So if K is equal to 0, what do we get? Q1 is equal to 0, or Q1 plus Q2 is equal to alpha minus C, right? So any point, any strategy profile in this region that satisfies this condition, profit, well, this is actually if and only if, profit is equal to 0. So all these points are on a iso curve. So let's draw that. So I have these points. Alpha minus C, alpha minus C. And then we have these points, no restriction on Q2. Okay. So actually, it's this region. Okay. But when Q1 is equal to 0, profit in this region is also equal to 0. So this region continues. So this indifference curve continues up that way. Okay. So this is one indifference curve on which profit is equal to 0. Okay? So, not the kind of indifference curves that we're used to in economics. Okay? Any questions? Any questions? So the case where k is different than 0, well, if k is different than 0, q1 cannot be equal to 0. If q1 is not equal to 0, I can divide both sides by q1. And then what do we get? We get q2 equals to alpha minus c minus q1 minus k q1. So this is what we were doing last lecture, right? So what does these animals look like? What does these indifference curves look like? So come on, try to draw it. Come on. Actually, let me make a small change here. I'm not good with subtraction. I'm very bad with actually elementary arithmetic operations. So addition is easier than subtraction. So let me write this like this. And let me give you a clue. You might want to consider two cases where k is negative and when k is positive. Come on. Simple algebra. We don't want an exact shape. We want a picture which will give us an idea on what's going on. Anybody have a picture and would like to share it with me? So that's the alpha line. So it should not, this only works in that region. Are you sure? Getting close, but not exactly. Getting close, but not exactly. Anybody would like to share their answer with me? Anybody have a picture? Would like to share? Well, we're only interested in this region, right? But think again. Think again. Getting close, but for some part at least. You see, when I look at this, this is a bit complicated thing, but there's this, just like one of your friends recognized last lecture, there's this linear part and there's this hyperbolic part, okay? So what I would do is think simple. That's what I usually do. There's the linear part. Okay. And there's the quadratic part. Well, the hyperbolic part, which will look like this or like this, depending on whether k is positive or negative, right? So this is the case where k is negative. This is the case where k is positive. That is profit negative, profit positive. So let's choose one of them. Profit negative, let's start with that. So all you do is add this to this, okay? The thing is, as your friend suggested, when q1 is small, this is very large, this is moderate. So there, the hyperbolic part would dominate the expression. So when you add them up, you would get something which starts like this. And as q1 increases, this term will be very close to 0. Hence, the shape will be dominated by the linear part. And as q1 goes to infinity, well, it can't. We have this restriction, but let's assume there's no restriction. It will approach asymptotically to this line, okay? So that's what I would expect to. Well, that's what I would expect to see when k is negative, right? Okay. So actually, if I put that up here, what I would get is something which goes on like this. Okay? Well, if k is positive, remember k profit negative, profit was negative here too. So that's a continuation. And when k is positive, that's what we have. So I'm adding this to this. Again, for q, small q, this part will dominate. So I will have something which goes on like that. And as Q1 increases, this will get close to 0. So the line part will dominate. So maybe I will have something like this. Okay. And as K increases, what happens? As K increases, this will shift down, right? Minus K, it will shift down. So this shape will shift down. Okay, that's what we will get. So if I add that here, I would be getting, when K is very small, not 0, but close to 0, but positive, this expression will have a bite when Q1 is very small. But then as Q1 increases, this will become negligible. So I will have something like, for very small q, I will have something like this. And for very small k, I will have something like this. And as k increases, these will what I will have. Again, putting an arrow to indicate direction of preferred alternatives is a good idea. Of course, I delete this part because the players can only play positive strategies. They can only produce positive quantities. So far, so good. So that's what the ISO curves look like. ISO profit curves or indifference curves looks like. Not the kind of stuff that we're used to in microeconomic theory 1, but this is game theory. Okay? Any questions? Very simple. Any questions? These are as profit, so it starts with a very large loss, okay? And then as we move on, the loss decreases, decreases, decreases. This is where the loss is equal to 0 on this indifference curve. And then as we go on, profit increases. Okay, oops. Okay, so far so good. Any questions? So this is the indifference curves, ISO profit curves of firm 1. And I can do the same thing for firm 2. Actually, take this picture, flip it around the 45-degree line, you would get something like this. Okay? That would be the indifference curves for firm 2. Okay? So we're talking about best responses using the indifference curve rather than, plotting the profit function and maximizing it. Let's look at the indifference curve. So I want to find the best response of player of firm 1 to the strategy Q2 prime of firm 2. How do I find it? Well, let's pick a point. Can this point be a best response? Well, not this point. Can the strategy of firm 1, which corresponds to this point, that is this strategy of firm 1, be a best response to Q2 prime? Can that be the case? Can this strategy be a best response to Q2 prime? Why not?
Because if we produce more, the indifference curve will shift down.
Okay. Well, this indifference curve will stay there, but we get the idea. So if you produce more, you're, for example, at this point. So remember the direction of the indifference curve was pointing in, which means that any point, any profile in this region is preferred to a profile on the indifference curve. So it's preferred to this profile, the profile where it produces the strategy. So it means that producing this quantity, for example, is preferred to producing this quantity. So this cannot be a best response. Okay? So something in this region is better. Well, any strategy of player 1 which corresponds to a strategy to this region is better than playing this. And it's better than playing this. Okay? So what do? Well, I take another point. Can this strategy be a best response? Again, the same reason. Anything inside is preferred to any point on it. So anything in this region is preferred to this strategy profile, which means that any strategy of player 1 which corresponds to a point in this region, is preferred to this strategy of player 1 and this strategy of player 1. So how do I find the best response? Yep.
You look at the indifference curve that's tangent.
Exactly. You look at the indifference curve that is tangent to this horizontal line. That's exactly what you do. Okay. So again, I don't even have to worry about that. So I draw several indifference curves, and then I have the indifference curve, which is, as your friend suggested, tangent to this horizontal line. Okay. So if he plays this strategy, he's on this indifference curve. If he plays any other strategy, firm 1 is at a lower indifference curve. Again, the direction of the arrows, that's why we had the arrows. Maybe I should have drawn it here too, okay? But I think we can remember it. The arrows were inward. So anything in this region is worse than the strategy profile. That is, given that player 2, firm 2 is producing Q2 prime, producing the strategy, the quantity which corresponds to this point, is preferred by firm 1 to producing anything different. Okay? So far, so good? So far, so good? Any questions? Okay? So that's how you find the best response using isoprophet curves, indifference curves. Draw, for firm 1, draw horizontal lines and look what they are. Tangent. Of course, you have to pay attention to the increasing direction. Okay? I'll show you, I'll show you where the tangentness will not work. I'll give you an example where I will not give you the example. I'll ask you to find an example where the tangentness will not work. Okay, but remind me, I don't want to forget. Sometimes I get overexcited and forget. Yes, sir?
What does isoprophet curve represent?
Isoprophet curve represents, so iso equal profit. So on this curve, at any strategy profile on this curve, the firm's profit is the same. Okay? So if his profit at this point, when firm 2 produced this much and firm 1 produced this much, if the profit was 2, it's going to be 2 here, it's going to be 2 here, 2, 2, 2, 2, 2, 2. Okay? So because all these points yield the same profit, and profit function is a numeric representation of the preference, firm 1 is indifferent between any point in this region. And because we had the increasing direction, the arrows pointing in this direction, so any point in this region is preferred, any strategy profile, any quantity pair in this region is preferred by firm 1 to any strategy profile on this curve. Okay? That's, well, yeah. Okay? So far, so good? Any questions? Any questions? Okay. So if we keep doing this, so draw another tangent, that's the best response. Draw another tangent, that's the best response. Draw another tangent, that's the best response. Draw another tangent, what is the best response? Not a tangent. Draw a horizontal line. What's the best response? It's 0. Why? Because, again, if you remember, maybe I should go back to this original picture. If I draw it, what's happening? Preferences are increasing in this direction, so we don't have tangency here. So this point is better than this is better than this, so it goes all the way here. Producing nothing is the best response of firm 1. Okay? So if we keep doing this, what do we get? That's what we get. Okay, that's the graph of the best response correspondence. That's the picture of the best response correspondence of firm 1. Any questions? Any questions? Okay. So we could use the indifference curves or the profit function itself in order to find the best response of firm 1. Okay. Well, looking at the indifference curves, looking at the picture of the indifference curve, some of your friends made the conclusion that they were able to decide on which strategies of firm 1 were strictly dominated. Can we do the same thing here? Dominated, so any strategy greater than alpha minus, well, here I had C1, C2, but in the original problem, the problem we started, we took C1 equals to C2. So any strategy greater than alpha minus C1 over 2 is strictly dominated by alpha minus C1 over 2. How do you see that from this picture? Actually, maybe let me give you the original picture. This one. How do you see that from this picture? Actually, let me do this. So let me draw the line. This is alpha minus C over 2. And that's some strategy Q1 prime bigger than alpha minus C1 over 2. How do you see that alpha minus C1 over 2 dominates Q1 star? Is what is higher than what? So start again.
Alpha minus C over 2 is on a higher difference curve.
Okay. Alpha minus C over 2 is at a higher indifference curve than Q1 prime. So far, so good? Any objections? Again, the idea is right, but the expression is wrong. You have to know how to talk the talk and walk the walk. So,
If we draw the parallel lines,
exactly. Yes. Okay, exactly. Now that's what you see. A strategy is not preferred to a strategy. A strategy profile is preferred to a strategy profile. So what you need is a strategy profile. So what your friend did was take a strategy of the second agent. If you, not a good choice for color. Okay. Now, take a strategy of player firm 2, take a strategy of firm 1, you have a strategy profile. Again, take the same strategy of player 2, firm 2, take the strategy Q1 prime of firm 1, you have a strategy profile. I can compare this strategy profile to this strategy profile, and as your friend suggested, okay, this is at a higher indifference curve than this one, if you look at the arrows. Okay? But the thing is, this should be the case for any Q2 prime. Okay? But when you look at it, you see these curves, indifference curves, get shrink, and the peaks of all these indifference curves is to the left of alpha minus C over 2. Okay? As we move on, the peak moves toward 0. So just by observing that fact, we have your friend's conclusion. Okay? Alpha minus C over 2 strictly dominates better, 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 better. So no matter what the opponent does, for firm 1, playing alpha minus C over 2 is better than playing Q1. Okay? Which means that alpha minus C over 2 strictly dominates any strategy that is bigger than alpha minus C over 2. Okay? So all these are dominated. What about these strategies? Are these dominated strictly or just dominated? Okay. So for that, you have to show that sometimes one is better, sometimes the other. Okay. So if you take any two strategies in this region, okay. So for this strategy of player 2, let's call Q1 double prime, Q1 triple prime. For this strategy of player 2, playing Q1 double prime is better than playing Q1 triple prime is better than playing Q1 double prime. But for this strategy of player 2, playing Q1 double prime is better than playing Q1 triple prime. Okay? So neither Q1 double prime dominates Q1 triple prime, nor vice versa. Okay? And the same thing works for strategies in this region. So all these strategies are undominated. Okay? So far, so good? Any questions? Any questions? Okay, so actually, let me work on this picture. So that's what we had. So if I do the same game, play the same thing with player 2, all these strategies of player 2 would be strictly dominated by alpha minus C2 over 2. And all these strategies of player 2 will be undominated. Okay? So if player 1 is rational, he will not play anything in this region. He will play something in this region. If player 2 is rational, he will only play a strategy in this region. Well, if player 1 knows that player 2 is rational, he will deduce that player 2 will not play anything in this region. If player 2 knows that player 1 is rational, he would know that he's not going to play anything in this region. Okay? And hence, they actually each know that they're faced with a game in which player 1 plays a strategy in this region and player 2 plays a strategy in this region. Okay? So far, so good? So far, so good? Let's take a break. After the break, we'll continue on this example. Attendance sheet, did everybody sign? May I have it, please?